Hello and welcome again. In this unit, I'm going to continue from the previous one on accessing JSON data from the internet. This unit will have a lot more code in it, and I'm going to work through it at a faster pace. The ideas are all the same. It's just that I want to show you a much more sophisticated, almost kind of getting into real world program that might be kind of useful. I say almost because it will still need a few tweaks. So to start with, I'm going to just reiterate that it's openweathermap.org is the site that I'm accessing. I registered on the site for a free account. That gives me very limited data. Again, I access that from the pricing page. Actually, it's a very handy page. I can make 60 API calls per minute at most, so 1 per second, which is something that's going to be very important to us. And there's some data that I can access here. So the current weather API is one of them. Let me just click on that, as I did last time. And this gives us the current weather data for one location. So last time, in the last unit, I created a very simple sketch that put up the current weather in a panel, something like this. So the weather for the current location, which was specified by latitude and longitude. Okay, I want to do something quite a bit more involved this time, and I want to access a whole lot of data for a whole lot of places in Ireland and plot them on a map. So this is, I'm going to show you how you do that without being super accurate, but good enough for a lot of programs. So we're not going to get into a heavy amount of geographical mapping data or anything like that. We're sort of going to fake it, but fake it in a nice way. So it turns out that they have a listing by city ID of all the weather stations that are available. And it says city list JSON GZ can be downloaded here at this sample. So that just gives me a directory listing, and sure enough, city list JSON GZ. GZ is just a compression format like zip. So I downloaded that and I had a look at what it gave me. And it was quite remarkable, actually. I'll just show you part. There's over 900 locations in Ireland that we can get the weather from. And if I go into, I've called this mapping. I have a sketch started here. I have a data folder. And if I open that up, you can see what the data looks like. I'll make it a bit bigger now. So you can see, first of all, the very first character is a left square bracket. So we know that the top level is a JSON array in this case. Last time it was a JSON object. This time it's a JSON array. And within that array, there's a number of different objects. There's one, there's another, there's another. Each one has an ID, the name of the weather station, and the coordinates in latitude and longitude. Super. So this is a catalog of all the places we can query for weather data. And then when we know which one we want, we can retrieve that weather data using the code from last week. Perfect. Now, what I have done is I've taken this and distilled it down to just this much. A small number of places that I picked kind of semi-randomly from the big data file. And the reason for this is we only get to ask the server for data once per second. So if I'm going to query these individually and I have 900 of them to do, that's going to take a ridiculous amount of time. So this service, the free version of this service, would not support that type of mass data query, at least not in this format. So this is my data format. We already know how to deal with this. I think it'd be really nice if we created a class that would hold this information internally in our program, and hold it in a way that would be the most useful for us. So let me get rid of that for now. So in this folder, I also have a couple fonts, a couple typeface files, I should say, and I have this. There we go, map of Ireland. And where did I get this from? Well, there are numerous sources for geographical data, but in this case, I just got it from Wikipedia. So I just did a search in Wikipedia and I found this. So Wikimedia Commons is a part of Wikipedia where they store all the media files, the graphics and so on. And this is available in a high resolution, and it was released by this user into the public domain. So no rights apply. In other words, you can use it freely, completely freely, which is nice. So yeah, so I downloaded this and I edited it. I got rid of this pink color because I don't want pink on my map. So I've created an outline of a program here already just to save a bit of typing. I've got my color constants at the top. I've set a pure green color here. I'm going to define two fonts. One for my title that will be black, so bolded and a bit bigger. And all my work is going to be farmed out to parse data. But to start with, I might want to think about my data formats. So if I'm storing location information, I want to do that in a class. So let me create a new tab, as I usually do for classes. I'll call it locations, and I'll just start thinking about what a location needs for this map, which is just it's not gonna do a lot. It's just gonna show temperatures, I think. We'll just stick with temperatures as an example. So every location is gonna have a position, and I'm gonna make them floats for convenience, even though pixels are integers. Every location is gonna have its temperature, which I will convert to an integer for convenience also. It's going to have a name associated with it, like a place name, which we already saw in the file. And we also saw that there's an ID, and the ID is really important because that's how we're actually going to retrieve the specific weather data from the server, is by ID this time. Last time we used latitude and longitude, but it's much simpler just to use one variable than two. So when we create this, oops. We basically want to give it all this stuff. So we'll give it its ID. So this is the constructor here of the class. We'll give it the name. And it's going to be getting the latitude and longitude out of the file, as we just saw in the data. Right, so I'll do it like this. So this is my standard way of doing parameters, which is I just put an underscore on the end. So ID underscore is a different variable name than ID, but it looks very similar. So I know that they're conceptually related. And in fact, the first thing I can do here is simply store that parameter as a property in my class. Same with name. But latitude and longitude, they're not so easy because I don't have latitude and longitude on my map or any way of knowing what that is. Where's my map again? There it is. So I went to Google Earth and I checked out the island of Ireland, and I sort of figured out, okay, this bit at the top here, what is the latitude there at the top? And what is the latitude at the bottom here? And then for longitude, likewise, like this is, whatever, it's like Greenwich is over here. So this is like -6 something, and this is -10 something in terms of that. So I sort of eyeballed it on Google Earth and tried to get it within a couple digits accuracy, which, admittedly is not like the best way to do this. I mean, the best way to do this would be to get this data and actually create this map with curves from real geographical data, but that's a lot of work. You might be into doing that, and that would be totally cool. But again, I need to make each of these lessons kind of bite-sized chunks of information and not get too carried away. When I get a latitude in, then I can map that onto a y coordinate. So what I'm doing here, I'll show you what I'm doing. The map function, oh my God, it's so nice. It's so useful. So I take my latitude value coming in, and that can be between the y position. So the top of the map is y equals 0, right? So, and that is 55.42 latitude from eyeballing it on Google Earth. And the bottom of the map is 51.38? Yeah. Sorry, get my cursor out of the way. And I'm going to map that onto the top. The y on my canvas is 0. And the bottom is the height of my map. So for now, I'm just going to call that map.height, with the understanding that there is no variable called map yet, but there will be. Okay, so that is really key. This is the magic. That is mapping real world latitude and longitude onto the approximate pixels where they occur on the map. And similarly, of course, you would do it for X as well. So the longitude. So X, when X is 0, that's the left side of the map, which is the furthest away from Greenwich. So it's the biggest negative number. If you know how latitude and longitude works, it sure helps. And that's on the width. Okay. So when I create a new location, I'm going to give it the real world latitude and longitude, because as we saw, that's what's in the data file. That's what we're going to get back. But I'm going to immediately map it onto X and Y and store it that way. So this location is a location relative to our canvas. Well, it's a real location, a location with position stored relative to the canvas. That might be a better way of saying it. But in any case, that's our location. So all this information we can get out of this file, but the temperature we need to look up using an API call, because it's going to change. And once we've looked it up, we need a way of getting that into this class, or into each instance of the class. And I'm going to create a method for that, which I'll call set temperature. So it's going to take the temperature and store that like so. So now we have all the information that we need for each location. The next thing we're going to need to do for a location, if you think about it, is we're going to need to somehow render it. But I'm going to come back to that once I have some better idea how we're displaying things on the screen. So again, in this case, I'm kind of working from the inside out. I'm thinking, what's our data structures? What are our objects? What do we have to store? What do we have to do with them? What do we need to do that? So in this case, the one thing we need is we need to know the map width and height, which we don't have yet. So they're floating around highlighted in red to remind us that we don't have that. And yeah, we now need a way to sort of aggregate all the locations together and store them. And we well know how to do that because we've had quite a few examples now, starting with our particle systems where we had a universe of particles and we stored them in an array within a class. And then more recently, we've used the more flexible array list. Yeah, let's do that. So, well, first of all, that's locations. We need a constructor, which is going to be empty. We're not going to do anything with the constructor, but we do want a way of adding a new location. Now, this is going to be just all this stuff again. So every time we add a location, we need to pass it all the stuff we need for the constructor. And then we need to go ahead and construct it. Now, I'm going through this quite quickly because it is very similar code to what we've seen before. There we go. Except that we don't need the ints and all that. They're already defined. Okay, so when we add a new location to our locations array, oh, right, we need to give this, we need to be, I haven't even defined it yet. Sorry, I'm working ahead of myself. I want to create an array list of type location. I'm going to call it loc, L-O-C, because I've already used it, that. And when I create it, it's a new array list. Redundant, I know, of type location. And then you have this bit of syntax at the end, which I can never figure out why it exists, but it does to make that work. So that defines our empty array list called LOC, loc, location, and each item in it is of type location, the class we made down here. Right, so then we can add using the add method, which is provided with array list. And what we're adding is a new location each time. And this will all be sort of tracked and appended and aggregated automatically in our array list. Yeah, so this gives us a bit of a sketch and is pretty well what we need to keep track of all our data. Right, going back to here then, how are we going to go about doing all this? Well, let's deal with the map first. The map is an image. So I'm not sure we've done much with images yet. P-image is our image type. And when we come to actually define it, let's see how we're going to do that now. We could do that in setup. Yeah, sure. Let's do that in setup here. So our map then we will load from our file. What was it called? Ireland.ping. There we go. Now we have a variable called map, which is of type p-image, and it's loaded from that PNG file. So now if I go back here, oh look, that error's gone away. We do have a map width and a map height that we can access in the same way that we can access width and height of our overall canvas. But in this case, I want to know just what it is for that map. Maybe maybe we should have a look at it. Maybe we should allow ourselves to see what it looks like. Let's put in our draw routine. We haven't had to write a draw routine in some time because I keep displaying static data. Let's put a white background, and then we will display our image. So it is the image function that does that. We'll put our map on screen at the origin. Let's see if this works. Yes, there it is. Now, I've deliberately created a canvas too big for the map. It's 1200 by 900, even though the map is something like 720 by 900. I've got all this area on the right-hand side, which I'm going to use as an information panel. I mean, that's probably too big, actually. I probably don't need it that big. But anyway, I'll go ahead and just do it. So basically, I want a side panel here for the information that I want to display, which in this case is only going to be the temperature, but it could be a lot more weather data from each place. So I'm going to fill that with the gray that I defined above. And I'm going to fill that. Now this gets a bit tricky, but the x coordinate of our rectangle will be our width of the map plus a border, I guess. I'll give it a bit of a border or a gutter. And then the y position, it will start at the top. Just thinking my way through this. The width of this rectangle is the width of the screen minus the map. Is that right? Yeah, probably. And the height is the height. Oops, we're doing the whole. We're doing the whole height. And then I can put a title in there because we've got our fonts defined. Let's use them. So make it black. Set our text font to our title. Do this so you can see a bit better, and then we will display temperature in Ireland. And we will put that on the screen where, well, here our side panel starts at map width plus 100. So we could do similar, maybe 140. And we'll put it, I guess, 40 from the top. So this kind of a 40 is kind of another gutter there, another sort of buffer zone that I could put in a variable and define, but I won't. Okay, what does this look like? Like that. Okay, so all I've done is this gray is just a rectangle I drew there. So I gave it the width of the map, which is about to here, plus another 100 pixels, just so there's a bit of a border around this. It's kind of cropped very tight here at the bottom as well. Yeah, so I define that first, and then I put our header text there. So that starts to look okay. I mean, that's an okay panel to be working with. You can adjust the proportions in that to be a bit more elegant, no doubt. What's the next step? The next step is probably to parse our data. Yeah. So how's this going to work in the big scheme of things? So we can parse all our data at the top here, which indeed I've already set up a function for that. I'm going to copy and paste from a working version that I have. Okay, so this is the locations.json file, and the top level is an array. So I use load JSON array, as I explained in the last unit. And I'm putting that in a variable that is type JSON array. And then because it's an array, I need to loop over every element of that. So I just use the size method as I would for any array. I'm going to loop over that. And for each one of these, then I get to add it to my locations class. But first, the parsing. So the first thing I do is get a JSON object. So that retrieves the contents of this at the ith position. So the 0th to start with, and then the first, and then with index 2 and index 3 and so on. And each one then I'm going to retrieve the JSON object here. And then I can start getting data out of that. So the ID is an int, so get int. The name is a string. And the coordinates is another JSON object. You can see with the braces there, the squirrely brackets, called coord. And once I have that object, I can go within the coordinates and get the two floats out. So just like last time, you drill down the branches of the tree to get to the little leaf nodes of data that you need at the end. And you do that with a sequence of JSON object and JSON array calls until you get to the data items, and then you use get float, get string, get int, whatever the data type is. And then I add that, all that stuff, the ID, the name, the latitude, and the longitude, to my places, which I actually forgot to define up here. I created locations as a class, but I didn't create an instance of that here. Which would look just like that. So define our places as actually I can populate it as well while I do this. New locations. Do it all in one line, like so. Okay, now I've got my places, which starts off empty. But each time through this loop, I'm going to be adding a new location to that here, to that array list here, using the add method. All things we've seen before, putting them together in different ways here. We also need to actually make some requests of the server to get the actual weather information. And to do that, we need our API key. And here's a fake one, because we do not share API keys, as I discussed last time. Something that will look up the temperature. Like last time, I need a long string that gives me my access to the weather server. Whoops, sorry, I scrolled too much. There we go. So there's my long string, and I need to put in the specific ID each time. So in the last unit, we requested the data by longitude and latitude. This time we're requesting it by ID, just because it's that little bit simpler, but the basic idea is the same. There's just different requests here that we can make on the weather URL. So I want to do this for every location I have. And let's use the handy dandy super cool notation where I specify a location L in my places, and I'm going to loop over those. Right, it doesn't like that. Can only iterate over an array or an instance of iterable. Yes, that's true. My places is an instance of locations. What I really want to loop over is the data within it. This. I can loop over an array. I can't loop over a class unless I specially write it so it is iterable, as was hinted in the error there. But that's too sophisticated for us right now, I think. So instead, I'm going to just loop over. Yes, and that works. I'm going to loop over the location array list within places. And each one of those is going to give me a location L. So again, this is the object looping syntax. That means that we do not need to keep track of a counter and an index. It is so much easier. So now I'm going to create my string, my full URL string from my prefix. And my ID, what's my ID for this location? It's L.ID. That's the property. And then the last part that I need to create according to the documentation, and just like last time, is I need to give it my application ID, my special key, like that. So that is how I create the request. It's all of this plus the actual ID plus the API ID parameter string, like that. And that will give me back a JSON object. And I know that by looking at the data that I get. I won't bore you with it right now because we've been looking at data and we know how this works. So load JSON object. I hope I got the capitals right. JSON ob. Didn't even spell it right. Never mind the capitals. Load JSON object from the URL. Same code as last time. Oh man, this is like so annoying typing that and getting it wrong. I'm just going to do this, copy and paste. So within that, there is a main. This is get JSON object from the main branch. You might remember. That B, I always make that B a capital. It's not capital. And then you also might remember how we dealt with the temperature. What we did was we, okay, first of all, we retrieve it. It comes to us in degrees Kelvin, so we need to convert it to Celsius. Like that. Then we round off. Like that. That's what we did last time. But this time there's a slight difference because we actually stored temperature as an integer. So I'm going to actually then, once we've rounded off, so rounding off does it properly, like it will round up or round down correctly. Once we've done that, we can convert it to an integer. You don't want to just convert to an integer because that just truncates the number. So 9.9 would be rounded off to 9, which you don't want. So yeah, you actually need to use round first. So that 9.9 is rounded off to 10.0. And then when you take the integer of that, you just get 10 without the 0.0. So there we go. That's that. So slightly similar to last time. And if we look at how we created our location, we have a setTemp method that takes the temperature. So now we want to call that. We've got the temperature now to store. And it's on our particular instance. Like so. So all the puzzle pieces fit. All the puzzle pieces fit. It helps to plan things out and sketch them out first so that you know the sort of objects that you need. Right, so this is going to loop through all our places, making requests of the server and getting the temperature for each location by its ID. So why is this wrong? That's a question to think about. Why is this wrong? The code is perfect. I hope. We'll find out in a moment. The code is good, but it's wrong to do it like this. Do you remember the restrictions on our data access? If I look at the pricing, free, no more than 60 calls per minute, 1 per second. 1 per second. If you make any more calls to the API than 1 per second, you're gonna get you're gonna be banned. So we need to delay very important. And I'll use a constant for that. So delay does pause by a certain number of milliseconds. And it better be at least a second. So just, whoops, a second, 1,000 milliseconds. I'm going to make it 1,100. And then we have a 10% margin of error in case, you know, in case the clock isn't quite accurate or something. Could be running faster than we want to. So now you see, even if we only have 9 locations, this is going to take us like 10 seconds just to retrieve the data. That's really annoying. And if we had all 900 locations in Ireland, we'd be here like waiting for this program to initialize its data like forever. Now okay, I want to test this soon, but we're not actually calling this yet. See, things get kind of tricky in our draw loop because, okay, we draw the image, we draw the side panel, and we put some titles in there. But then what we do next is really going to depend on where we are in the process. I've just said it's going to take us 10 seconds just to load the data. We don't want people looking at it going, you know, the program's frozen or it's not doing anything. We do need to tell the user something. So I think when we first start going through the draw loop, we're going to have to, we're going to have to sort of, you know, put up some sort of loading screen or, you know, please wait while we access your data. So for the first, now this is tricky to do for a reason that I will, it's trickier than you might think for a reason I'll get to here. So for the first, let's say frame count less than 10. I found if you say if frame count equals 0, like for the first frame, sometimes it doesn't trigger. It's like sometimes it, you know, it goes too fast. So I'll just say less than 10. And actually, you know what? Let me go way up here to the setup and let me just set a frame rate. Yeah, let's set a frame rate so that we actually have some kind of vague idea as to how many frames is what length of time. Now I've mentioned that this is not accurate. If you set a frame rate to 24, it does not mean you're going to get exactly 24 frames per second. It depends what the program is doing in the sketch. If you have very complicated graphics, it might not be able to do it that quickly. It varies from there, but it's approximately 24, so long as we're not pushing the graphics too hard. And we're certainly not in this case where we're just displaying a map to the screen so far. So, right, let me go back down then to the draw. So that means about half a second. So for the first half a second, I want to tell people what's going on here. So I want some text. And let's use our normal font, not our capital font. And let's display what we're doing. We're polling the server. We're retrieving the data. So we could say retrieving data, dot, dot, dot. And I better place that. Yeah, see, this is kind of tricky. We're going to need, just like one of our early graphics examples where our program occurred in different stages and we had to keep track of which stage we're at. I think we're going to need to do that here as well. Yeah, so it'll make our code easier. See, I told you this unit was going to be more involved. So let's have a status string. Oops, not all caps. Yeah, we can update it to, I don't know why I made a capital S there though. We can update it as we go. Okay, so to begin with then, at the beginning of our program, when frame count is still low, we're going to write retrieving data. And how long do we want that on the screen for though? So the first case is the first like half a second. We want to just initialize something, initialize status to this read because we're reading or retrieving or whatever you want to call it. And then the next condition then will be when the status is equal to that. So the next time through the loop, then if status is equal to read, whoops, sorts of little errors here. Then we can do something else, you see. And what we want to do here is retrieve our, get temperature. Which actually gets all the temperatures. Should we get temperatures, I suppose. And when that's done, we can pause for a while so that the user has a chance to read what's going on the screen. Okay, so see, the root problem here is get temperature is a blocking operation. So let me write that out here. We are in a graphics program where we want people to have access to the screen and be able to do stuff at all times. But get temperature in this case is going to completely go away and do its own thing, during which time we are not looking at mouse positions or cursors or anything else that's going on. We've blocked our interface. That's really bad design, but I'm going to leave it that way because of time constraints, really. It would make a lot more sense if we could multitask and let the user do something with the program while this data is being retrieved. Maybe. Another way to deal with it is, say this was set up as a kiosk sort of display. You could have a sort of, you could have a state. Say you had to go in and turn on the computer in the morning and then it would run this graphical thing. Well, if it took 5 minutes or 10 minutes to boot up and to get all the data for the day, that would be fine. And then during the day, it could update the weather data sort of periodically. It could sort of randomly choose maybe one of the locations every 10 minutes and just do that one update, which it could do instantly without blocking. So that would be better code, but it would also be much more sophisticated code. So I'll leave that for you to work out if you have a program that has to take a long time doing some operation. But just so you know, that's called blocking. It's a bad thing because people don't have access to the program in the meantime. Everything freezes while it's doing something. So we'll see that in a moment. So, okay, so we're going to pause, but how long are we going to pause? See, we need to keep track of that as well. We need like a marker so that we know when to lift the pause. So why don't I just call it marker? And whatever the current frame count is, we can add 2 seconds. So this is why I set the frame rate, because I know that that's about 2 seconds now. Okay, so marker is an integer, and I need to flip up here. To define that. So now we basically have different, we're basically flipping from one status to the next. So now the next status that we need to take care of is when we're paused. Pause, it's called though, not paused. Let me put empty lines here to make this a bit nicer for you. And then let me scroll down like that so you can see what's going on. So what we want to do now is basically say that we're done. So it would be similar to this. Remember that each time through this draw loop, the background is getting wiped, the image is being redrawn, the side panel is being redrawn, and the title on top of the side panel. So if you want anything else drawn, you have to do it explicitly each time through the loop. That might be obvious, but here we go. We can just say it's done and put that in the same place as before. And how long are we pausing? We're pausing until we get to this marker, and then we need to set some new status. So I don't know if I showed you this exact method before of sort of cycling through different stages in a program. We might have. And now we can just go. Status equals go. Yay. So if our frame count is greater than our marker, which is another frame marker, then we will no longer be paused. We'll change the status to go. And then our final status, where the rest of the stuff will happen, is where we actually open up our interface for use, is go. Right. That's kind of crazy. Let's see what it looks like. I have a syntax error. Try again. Temperature on retrieving data. Oh, I have an error down here though. So let me stop that if I can. Yep. Null pointer exception. Ooh, those are evil. Oh, all right. Yeah, I've got a fake application ID in there, so it's not going to get very far, is it? I actually have to give it my real key and actually go ahead and retrieve this data. Right, so I've put in the API key, the real one, and now if I run the program, it's actually going to be retrieving the data. Retrieving data. It's making 9 requests to the server. So, done. And then it disappears. Yay! So that's what happened. So the first 10 frames, it put up retrieving data, and then switched to read mode, which immediately ran the get temperature, which is the one that makes requests of the API, which was a blocking operation. So until this is done, it's never going to update the screen. So the retrieving data stays on the screen. When it's done, we update to pause and we say 2-second pause. Maybe I'm going to I'll make that slightly more. And so the next loop through, it's going to hit this block, which says retrieving data done. And it's going to do that for 60 frames before it switches the status to go. So if we try that again, we have a map Presumably, we have all this data now retrieved behind the scenes and stored in our array list, in our places instance. So what will we do with it? Well, it makes sense that when we mouse over that place, it might show us the information over here in the panel. So we need to track the mouse pointer and see what data is close by the mouse pointer. And this is a technique that's used quite often. It's a really handy, responsive way of dealing with the data. And we're gonna tuck it all in. We're gonna tuck it all in here. There's not much to it. The first thing we want to check is that our mouse is indeed within the map area, because otherwise we don't need to do anything. So if mouse X is within the map area, because remember our canvas is bigger than our map. Whoops. If so if mouse X is less than the width and mouse Y is less than the height of the map, then our mouse is over the map somewhere. So we'll do something with that. So what we want to do is figure out which weather station is closest to the mouse. And that's going to return one of our locations. So we're going to get a location back from some sort of a function, some sort of a method in our places that's going to do the work for us, because places is our class that knows all this position information. And I'm going to call it, use a fancy term, call it proximal. I love that word. And of course it doesn't exist yet. So this is going to return a location, the closest location to our mouse cursor. That's what this does. And we just, and then what we can do is we can render. Now I know right away there's a problem here, but we can render that location and actually display it. So now we need two things. We need a render routine in our location, and we need a proximal method in our locations. Location and locations. So we need a render here. And what's that going to be? We'll just put a dot. We'll just put a dot on the screen, will we? At the correct position. And we have a green color to use. Let's use green. So ellipse or circle. I always use ellipse. I don't know. I just pretend like circle doesn't exist. And the position is X and Y, and let's make it maybe 20 pixels. Nice and big. Learn how to spell ellipse if you're going to use ellipse, Robin. So that's going to put the dot on the screen, and then we can, well, I'm not going to bother copying and pasting. I'll just type this out again. We can get a black text. And actually, I do need to copy. I need to remember where these are. So this is at this position. Okay, let me just copy that. It'd be a lot easier. So it's got the location and the temperature. So at such and such a place, the temperature is, yes, okay, at, what's our property here? Name. At name, the temperature is temperature. Degree C. There, just do that so we can read it. Okay, so at Cork, the temperature is 14 degrees C, for example, and put that the same place as all our other text has been. Yeah, that sounds good. So the rendering, there's two parts to the rendering. There's putting something on the map, and there's putting something over at the side on the sidebar. So place location on map. Info in sidebar. I mean, we could print that all on the map if we wanted to, like sort of create a floating window or some sort of a call out there that would look nice, but that would take more graphics, more lines of code. I'm trying to keep this as minimal as possible, though you might not be believing that at this point. So that renders the location, and in fact, I can now say that that's all this class needs. So there, it fits on one screen. That's it. That's all this class needs. And then locations needs proximal, except it's not void. It returns a location. We need to test every one of our locations. So let's loop through all our locations and then figure out what we need in terms of variables in a moment. So for location L in our locations, how far is that location from the mouse pointer? What's the distance? Well, we have a distance function. So the distance of the distance function takes 4 values. It takes 2 points. So it takes our LX and LY, because that's the location we're testing right now, the X and Y positions. And the second coordinate pair is mouse X and mouse Y. So this gives us the distance. And if that's, we want to find the closest point, so the lowest number here. So whenever that's the case, we want to find the minimum. So if we set up a value and make it the biggest value possible, then all other distances will be less than that. This is how you do minimum calculations. It's a bit counterintuitive at first. You initialize your variable that's going to hold your answer. You make it the biggest possible number. And then, as you test each d against it, you can replace it if d is lower. So if d is less than minima, we can make it the new minima. And at the same time, save the current instance, because that's what we want to return. So we also need to initialize some result that's of type location. And I guess it's null to begin with. Null is this magic thing you can use. Right, and then the only thing left to do is return. So let's flip back out here. Just to explain one more time, if our mouse is within our map, we will now use that function, that method on places, to determine the most proximal, the closest location, and we will render that location. I'm really wanting to see this work. Retrieving data. Boring wait. Take a sip of water. Okay, done. That displays for a couple seconds. Okay, I'm moving the mouse over here. Nothing's happening. Oh, look. Ah, nice. I actually didn't expect that to work first time. At Westport, the temperature is 7 degrees. At Ennis, the temperature is 8 degrees. At Lumnech, the temperature is 7. Seems really weird. Limerick has the Irish name, even though like no one uses it. At Cork, see, it doesn't say Corca or whatever. It's Corke or Corca. I can't remember now in Irish. Sorry, it doesn't say that though. It says Cork, 6 degrees. Oh look, we have Kilkenny. Where else do we have? Ah, we got Dublin. Ah, Dundalk. Sligo. No, we're up in Donegal though. Okay, I just Kilkee. Yeah, you gotta know what it's like at the beach, right? And Ennis. There we go. So yeah, this is okay. I mean, I think this works. I'm not going to do anything else. I mean, one thing you might want to do is, I mean, look, my cursor's way over here, and it's saying that's the closest. Like, you might want to put some minimum distance here so that it only does that if, you know, if you're within, I don't know, 60 or something. In fact, you know what? That's like so deadly easy to do. That's Proxima. So if D is less than minima and D is less than, I don't know what number of pixels, but I'm going to just say 60. I'm going to say 60. Then you can return the result. So, yeah. Okay, it could happen then that because your mouse is way off to one side, nothing hits. Now that we've done that, it's actually very possible that no location would be close enough. So when you return the result, it's going to be equal to null. You really have to watch out for what are called boundary conditions in your code. I've been doing this for so long, I just think of them automatically. So yeah, I can right away see that just by doing that, I've created a possible problem. So proximal is being called here. If it returns null, and we try to render null, that's a pointer error. So I actually need a test here. Just one more line. If L is not equal to null, you can test in this way, then render. Otherwise, there's nothing to render. Yeah, that's safer. Okay, let's see what this looks like now. Let's run this. Retrieving. Da 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 da. If I play a little tune, that would actually help. Good. So see, if I'm in here, Meath or wherever I am, then I'm too far away from any point, so nothing is showing up. That's actually better. I think you need to be like a certain closeness. Like if I'm in Dunleary, oh, that's still right. Dunleary's like really close. But if I'm, yeah, I don't have any locations for all of these counties. Sorry about that. Sorry about that, friends in Waterford, which is, I guess, here, or Wexford. Kilkenny at least gets one. Yeah, okay, cool. So this is something to build on. So yeah, we finally have an example now of interactivity and visual display. Our previous examples were mostly concerned with the data access and the code thereby, but due consideration should be paid to how you're representing the information. Now, this big side panel is kind of ugly. I did that just as a quick hack. You might instead want the information to float up here around the mouse pointer. Obviously very simple to do because we know where the mouse is. And we could just sort of build a nice little floating window out of different graphical elements if we wished. But there's obviously different enhancements. And you would want to get more data in here. So I mentioned one possible way of doing that earlier, which is to simply have an offline period, even if it's 5 or 10 minutes, when this program accesses all the data it needs. Obviously, that doesn't work if you want it to be quickly interactive on the web or on the desktop like this, but it might well work in a gallery or a museum situation with an interactive display. Quite often, setting things up for that, it's okay if it even takes like half an hour to boot up and configure everything. So yeah, depending on the context, will obviously change your constraints and what you might need to do. But it's time I stopped talking, and it's time you had a chance to look over the code, which of course I will make available to you. So please check it out. Understand as much of it as you can. Break it down section by section. We are now at the point where apps are getting, fairly complicated by our earlier standards, but really this is still not very much code in the big scheme of things. It's still quite reasonable, but effective, I think. Effective. If you can imagine this having more locations, it'd be quite nice. Okay. Robin signing off. Over and out.